5.2 is just the factored form of the parabola. So far we've done vertex form and standard form. And then we used completing the square to go from standard form to vertex form. So this is just another form that you can have in your back pocket. That's really all it is. And so it says, what if the quadratic equation is in factored form like this one here? It says y equals x plus 2 times x minus 4. So how do you know the graph will be a parabola? So how do we know if something is a parabola? What does the equation have? An x squared, which is how many x's? 2. So although factored form doesn't have an x squared, it has 2 x's. So we know because it will have 2 x's, which will makes it quadratic. Okay, 2 x's, which makes it quadratic. Yes? And so that's what tells me that it is a parabola. Now, how do I know when the parabola opens up or down? What tells me that? If the a is negative. So it's kind of hard for me to see my a value in factored form. So let's go ahead and FOIL it. So I would have x squared, and then I would have minus 4 plus 2, so minus 2x minus 8. And so when I look at it in that form, I can tell that my x is positive, right? Now, you can tell that also by looking at the factors and just knowing when you multiply those 2 x's together, they're both positive. And so it would be a positive a. So does the parabola open up or down? It opens what? Up, because a is greater than 0. It's positive. A is greater than 0. Or positive. Okay. What are the zeros, the x-intercepts in the function? So remember all the way back at the very beginning of 5.1, and you might even want to flip to it, we did this little section of reviewing factoring and talked about how when we were solving an equation, finding x, that meant we were finding the zeros, the x-intercepts, or the roots. So to know what the roots are, or the x or the zeros are of this function, what would I do to my 2 factors? What do y'all think? To x plus 2 and x minus 4. To find x. Make it equal to 0. So I would have x plus 2 equals 0 and x minus 4 equals 0, giving me x equals negative 2 and x equals 4. And those are x-intercepts, which I like to write as points, and I would like you to write as points as well. Anytime it's asking for an x or a y-intercept, rather than just solving for x, go ahead and take that extra step to solve for, or to put it in coordinate points. Okay, so looking at just this equation, y equals x plus 2, x minus 4. Do I have enough information to sketch the graph without doing any math? Like, you know how in vertex form you can look at it and you can see, oh, I'm going right, up, reflecting, all those things. Can I do that in standard form or in this factored form? No, I cannot. So I do not have enough information, so no. So what do I need? I need the axis of symmetry. It is. So that is one way to do it. So we could come over here and we could graph negative 2 and positive 4. And our axis of symmetry is going to be in the middle. So 1, 2, 3, 4, 5, 6 points in between. So that means 3 points in between. 1, 2, 3 is my middle. So there is my axis of symmetry. So that is definitely a valid way to do it. If I didn't have a graph, what would I do to find the axis of symmetry? What formula? B over 2A. And so for that, I need it to be in this form. Negative B, thank you, yes. So it would be negative 2 over 2 times 1, which is what? 1? 2 over 2? 1? So my axis of symmetry is at 1, which, yes, you can totally just graph the points and find the middle, right? And then what else do I need? I need the axis of symmetry and what? The vertex. I need the vertex. Okay. How do I find the vertex? I plug the axis of symmetry into the equation. We can plug it into the standard form or into the factored form. So let's plug it into the factored form just to keep things interesting. So I have y equals 1 plus 2 times 1 minus 4. Are we following what I'm doing? Yeah? So then 1 plus 2 is 3. 1 minus 4 is negative 3. And so negative 9 is my x value. So my vertex is at 1, negative 9, which very much unfortunately is not on this graph. The old version of these notes had a graph that could accommodate a negative 9. And then somebody changed it. I don't know why. I'm going to change it back next year. But we can just pretend 1, 2, 3, 4, 5, 6, 7, 8, 9-ish. There. Oh, I need to go over 1 though. Sure, that looks good. And then connect our dots. Okay. So this is basically just showing us that we can use the factored form if we need to. I prefer to use standard form or vertex form. And so a lot of times if I see factored form, I'll just go ahead and FOIL it out. That's what I like to do, but you don't have to, okay? So like even with the next one, something a little bit more simple. So sketch the graph of y equals 2x plus 1, 2x minus 1. So we've got factored form. Our zeros are going to be when these are equal to 0, right? So I would do 2x plus 1 equals 0 and 2x minus 1 equals 0, like that. And so then x would equal negative 1/2 and positive 1/2. Now notice it says that it's asking for the zeros, not the x-intercepts. So I'm not as particular. When it says x-intercepts, I want it points. But if it says zeros or roots, you can just leave it as x equals, okay? So then I would come over here to my graph and go 1/2 and 1/2. There are my zeros, okay? And then how did you find the axis of symmetry earlier, 7? Good. It was in the middle of the zeros. So for this one, where is the axis of symmetry at? Good. X equals 0. And then to find the vertex, I just plug 0 in. So I would have y equals 2 times 0 plus 1 and 2 times 0 minus 1, which is just 1 times negative 1, negative 1. So my vertex is at 0, negative 1. So right there. He looks like a reindeer to me. Do you see it? His eyes with his big nose. He's Rudolph. Rudolph. Are you Rudolph? And then the arrows are his antlers. PH? Yeah. No. Oh, yeah, it is, isn't it? I teach math. Rudolph. Okay, anyways. I think it's just because my bottom dot was so big. But does this make sense? This is a good old-fashioned true-false section. So it says use the graph of f of x equals ax squared plus bx plus c to decide if the following is true or false. So it doesn't give us any equation. It doesn't give us an equation. All it gives us is the x-intercepts, which are at -2 and at +6, right? So that's all I get. And the first one says axis of symmetry is at x equals 2. So I can look at my graph and go, okay, well, what is exactly in between 6 and -2? So in between 6 and -2, how many steps are there per se? 3. Between -2 and 6. Between the whole distance. The whole distance is 8. The whole distance is 8 units. So the axis of symmetry is going to be where? At how many units? 4. It's going to be halfway at 4 units. Okay? And so then I think, okay, well, 4 units from 6. 6, 5, 4, 3, 2. So it's right here at 2, 0. Is my axis of symmetry. So, is that a true statement? Yes. Yes, it is true. Okay. The next one says the vertex is at 2, comma, f of 2. So this actually goes all the way back to lesson 1.2 from unit 1. Okay. Lesson 1.2, which was the one where we would have a graph and it would say like, okay, f of 2 equals what? F of 7 equals what? And so we would have to know where x equals 2, where is y? Y'all remember doing that? X equals 2, where is y? So x is at 2 for the vertex, right? Because it's where the axis of symmetry is. So we're trying to figure out where x is 2, where is y, which does that track with what I need for the vertex? I'm trying to find where the y value is at 2, right? Because it's going to be somewhere, what's happening? Somewhere down here, right? Yes. At 2, f of 2, okay? So that is a true statement. Okay, the next one says that A is what? Is that a greater than or a less than sign? Less than. A is less than 0. What would that mean? False. Good, it's false. This would mean opens down. But we're opening what? Up. Okay, good. Now it says C is what? Less than 0. Now, what does the C value stand for? The y-intercept. So the y-intercept is less than 0, meaning it's negative. So no. Well, here's the y-intercept, right? Oh, somewhere here? The x-intercept. Yeah, but the y-intercept is down here. So it's true because it's less than 0. Okay? And then the last one, it says f of 1 is equal to f of 3. So let's look at this. F of 1 and f of 3. F of 1 is like, if this spot right here is, on my axis of symmetry is 2, then 1 would be like right here, right? And 3 would be like right here. 1 and f of 1 and f of 3, so where x equals 1 and x equals 3. So here's my axis of symmetry, right? At 2, 0. X equals 1 is 1 to the left. X equals 3 is 1 to the right. Would you agree?
So yes, it's right.
So they're both one step away, right, from the axis of symmetry. Would you agree?
I understand.
Yeah. So if I'm looking to see where my graph falls there, oh, there and there. So they both fall about right here. So they're in the same spot. I know it doesn't really look like it in that picture, but.
What?
So think about when we use quote slope, how quote slope is like only one step to the right and left, right? But it's the same. So if I'm at my vertex, it's just saying the distance is the same. Yes. Which is true. Now, if it was 1 and like 4, well, 4 is 2 steps away, 1 is 1 step away, so that would be false. Does that make sense?
Yeah, that makes sense.
Okay, good. Okay, so true. Good. So that's kind of a complex true-false section that I just wanted to go over.
Complex.